A very warm greetings from Rohini College of Engineering and Technology. Welcome you all to this video lecture. I am G. Thangam, Assistant Professor, Department of Physics from Rohini College of Engineering and Technology. I am handling the subject Physics for Information Science with the subject code PH8252. So in this video lecture, I am going to discuss about extrinsic semiconductors. So the different types of extrinsic semiconductors we are going to see. Course outcome: after successful completion of this topic, the students will be able to interpret the types of extrinsic semiconductor. So before moving on to the types, first we should know what do you mean by extrinsic semiconductor. So extrinsic semiconductor means it is an impure form of semiconductor. So already we have studied about intrinsic semiconductor. So intrinsic means it is a pure form of semiconductor, that means without any impurity we have a semiconductor. That semiconductor is called intrinsic semiconductor. Now we are going to discuss about extrinsic semiconductor. So it is just opposite to intrinsic. So it is an impure form of semiconductor. So how we can make this as a impure form? By adding impurities. So with the pure semiconductor, when you are adding impurity, you will get extrinsic semiconductor or impure form of semiconductor. So we are going to see what do you mean by doping. So when you are adding impurity with the pure semiconductor, we have some process. That process is called doping. There is an addition of impurity with the pure semiconductor is called doping. Depends upon the impurity added with the material. These extrinsic semiconductors are classified into two types. One is N-type semiconductor and the other one is P-type semiconductor. So N-type, from the word itself you can understand it is the negative type. P-type means it is a positive type semiconductor. So N-type means negative, so the charge carriers are electrons. P-type means it is positive, so the charge carriers are holes. So we can move on to the type. First we can see about the N-type semiconductors in this video lecture. In the next video lecture, we can discuss about the P-type semiconductor. So to understand about this N-type semiconductor, let us consider this diagram. So we have two color balls, one is red, another one is blue. So the red color balls are silicon. So they are pure semiconductor without any impurity. And with this pure semiconductor, one element is added there, that is phosphorus. It is denoted as P. So this phosphorus is added with the silicon. So an impurity is a phosphorus. That impurity is added with pure semiconductor. So it automatically becomes impure. So why we are calling this as N-type semiconductor? Here this phosphorus is a pentavalent element. Pentavalent means it has 5 valence electrons. So normally in this diagram we have silicon atoms, large number of silicon atoms, and with this we have phosphorus. Around the silicon, red color silicon atom, we have green color flower like structure. So in the structure we have dots. The dots are electron. So around one silicon atom we have 4 electrons. So the valency of silicon is 4 because 4 valence electrons are there. Now when one silicon is connected with the silicon means they are connected with the covalent bond. That means in between the silicon we have a covalent bond. Covalent bond means there will be a bonding between 2 electrons. So here when a phosphorus is added, phosphorus has 5 valence electron, but for making covalent bond with the silicon, it needs only 4 valence electron. So 4 valence electrons are forming covalent bond with the phosphorus. So due to that, another excess electron will be there because phosphorus has 5 electron. 4 electrons are used for the covalent bond. So 1 electron will be excess. That electron is denoted in this diagram as free electron. Why we are calling this as free electron? Because it is not making bond with any silicon atom. So it is free to move anywhere. So if you are having a free electron means automatically there will be a production of current. Free electrons will be in the conduction band. So here first the pure semiconductor added with the impurity. Due to the addition of impurity we have a free electron. So it behaving like a conducting material. So before that it acts as a insulator, and after that it is behaving like a conducting material. That's why we are calling it as a semiconductor. And just like that, if one more phosphorus is added with another silicon, another one free electron will be created. Another phosphorus is added means another free electron. So depends upon the addition of impurities, the number of electrons will also increase. So this, due to the increase of number of electrons, we are calling that as N-type semiconductor. Okay, so when a pentavalent impurity, because the phosphorus is a pentavalent, is added with the pure semiconductor, it is called N-type semiconductor. Now we can see the energy level diagram for this N-type semiconductor. So that is shown in this diagram. So we have two band. One is conduction band, that is denoted as CB. Another one is the valence band, that is denoted as VB. So in between this conduction band and valence band we have EF, that is below EC we have EF, and below that EF we have ED. This ED is called donor level, and in between the conduction band and the valence band we have a gap, that is called EG, because this donor level is just nearer to the conduction band. Why? It will donate electron to the conduction band, because the electrons are free electron means it will be in the conduction band. That is why the donor levels are just nearer to the conduction band. So this is about the energy level diagram for the N-type semiconductor. From the donor level, for an example, one electron is moving means it will move to the conduction band. When an electron is moving from the donor level to conduction band, one hole will be created in this donor level. So in ED level we have a empty hole. The empty dot is there, that empty dot is called hole. Another one electron is moving to the conduction band, so one hole will be created in ED. So the number of electrons in the conduction band will be equal to number of holes in the donor level. To find out the carrier concentration and for the Fermi level, we can use this condition in N-type semiconductor. So that's all about some basic things in N-type semiconductor.